All right. Good morning, Lorenzo. How are y'all doing today? Good. Awesome. Um. So my goal, my job for today is to address your questions over the review. Um. But I'm going to begin class today with just addressing a few things that were brought up in my 9 o'clock class. Um, before we get started. So, number one, um, and facilitator, if you're listening, you'll want to listen to this. Number one, the exam is going to be in two parts. You get part one on Wednesday, part two on Friday. Um, the exam is not going to be 50 questions like you see on the review. The review is only there to say, hey, these are things that you need to be aware of, know how to do in case I test you over concepts like this from the review. Um, I don't know how many questions are on the exam. I don't know how many questions are on part one or on part two. I haven't um, decided on that yet. Facilitator, you will be getting the exam from me either this evening or in the early part of tomorrow morning. Um, and you'll also get specific instructions on how to administer the exam and how to get the exams back to me. Um, you'll have the 50-minute time slot that we have in this class to take your exam part one and part two. Um, and whatever you don't get done, you just don't get done. But I designed these tests so that if you know what you're doing, if you know the process or have a good understanding of the processes required to solve these problems, then you shouldn't have a problem finishing the test. Um, anyways, that's number one. Number two, calculators. As stated in the syllabus, no cell phones are allowed and no graphing calculators. You are not allowed to use a graphing calculator. You need to have a basic scientific calculator. Um, I normally have a blue one of these, but I lost it. I don't know where it is. I bet my 2-year-old has it somewhere. Um, you don't have to have this calculator, but this is what I use. Um, I use a version of this, the TI-30X2S. Um, Target has these on sale right now for like 15 bucks. Um, Amazon and Walmart. I looked at Amazon and Walmart. Both of them are around 25 bucks, but you can get it at Target for 15 bucks. Um, so if you're going to use a calculator, that's the kind of calculator you need. This first test is designed in such a way that you don't need a calculator. Um, it might be helpful with some of the word problems that we do, but I designed these tests so that even in the word problems, if you're doing some percentage things, you can just do it off to the side, do a little bit of side work. These tests are designed so you don't have to use a calculator. So anyways, no graphing calculators, no cell phones. Anything else that was asked in the first class that I want? I think that's it as far as questions that I got from the first class regarding the exam. Um, so my job here is to answer questions over the review. Now, um, I've already addressed some questions in a 9 o'clock class. In fact, here's what I want you to do. I'm about to announce the questions that I went over in the 9 o'clock class. If you have questions over these problems, watch the video from the 9 o'clock class. When it gets posted up to YouTube, you will have access to the recording of the 9 o'clock class. So, if you have questions over, I hope you're ready for this, problem number 34, 50, problem number 5, problem number 8, or problem number 20. Do you need me to repeat those problems? If you have questions over those problems, watch the 9 o'clock video. I don't want to go over those problems again. Watch the 9 o'clock video to see how to address those problems. And I told my 9 o'clock class that we're going to be looking at different problems. I'm going to ask y'all to ask questions about different problems if you have any questions. And I told my 9 o'clock class to watch the 10 o'clock video. So I just don't want to go over questions twice. So you already know what I've gone over already. So I will be more than happy to answer any other questions across the homework set or across the unit review. The other question that was asked is, am I going to put up a key? And the answer is no. I don't have a key made for this, and I just don't have the time to make a key. If there's questions about certain problems that if you want to know the answer to, feel free to email me, and you can inquire about what the question is, and I will do my best to reply to you at some point tomorrow to address your questions, but I will not be putting up a key for this review. Alright, enough talking from me. How can I be of service to you? I didn't hear that. You may want to turn up your volume. Oh, your volume should be fine. Try again.
Can you go over question number 3?
Problem number 3. Three over x plus 3 equals 5 over a 2x plus 6 plus 1 over x minus 2. So what we have here is we have a rational equation. Denominators in the variables in the denominator. So these all kind of work the same way. We went over problem number 5 in the last class, so you can see problem number 5 worked out in the 9 o'clock video. But the first thing I'm going to ask myself is, does anything factor? Can any denominator be factored? And this one can't, but this one can. There's a GCF for this denominator, and that GCF is a 2. So this is kind of illuminating, because when I factor out this, I'm left with a 2 times an x plus 3. Well, there's an x plus 3 right there. So when it comes to determining what your LCD is, because we want to make the fractions go away, I was talking about this idea in one of my other classes. The LCD has to be something that makes all your denominators go away. Well, you see the common expression of x plus 3? Well, that has to be in our LCD. Now let's talk our way through this. If I multiply everything by this, LCD cancels out with x plus 3, so that fraction's cleared. If I multiply the LCD by this term, well, the x plus 3's go away, but what's still left? The 2. So we need a 2 as a part of our LCD, because now when I multiply the LCD by this second term, the 2 on top is going to cancel out with the 2 below. The x plus 3 is going to cancel out with the x plus 3 down below. No more fraction. Now, if I multiply the LCD by this third term, nothing cancels out. This 2 does not cancel out with that 2, because you have to think about this x minus 2 as one thing. So what do we have to add to our LCD to make this x minus 2 go away? The LCD needs a x minus 2 attached to it. So I'm going to write this out. 2 times the x plus 3 times the x minus 2 over 1 times the 3 over x plus 3 is equal to my LCD. I'm going to do, because it'll take me less time to do this. Okay. Alright, let's put that 3 times the x plus 3 back equals, there's my LCD again, times the 5 over, I'm going to write it in the factored form, 2 times the x plus 3 plus my LCD again times the 1 over x minus 2. So what we've just gone and done is we've taken this LCD and we've multiplied it, distributed it to every single term in our original equation. So let's talk about how things cancel out. X plus 3 cancels out with x plus 3. 2 cancels out with 2, x plus 3 cancels out with x plus 3, and the x minus 2 cancels out with the x minus 2. So I'm left with 2 times an x minus 2 times 3 is equal to an x minus 2 times 5 plus 2 times the x plus 3 times a 1. With me so far? So, now we got to go through and solve. I would go ahead and multiply the 2 into 3 first. I'll distribute the 5. And, 2 times 1 is just 2, so I can ignore this 1 and distribute the 2. Now I'll distribute the 6. Let's see. Let's simplify the right-hand side. That's going to be 7x minus 4. Alright, I'm going to subtract 7x on both sides, so we get negative 1x. I'm going to add 12 to both sides. That's going to give me a positive 8, which means that x is equal to a negative 8. Now, way back up here at the initial problem, I'm just going to scroll up to the initial problem real quickly. I should have made this note before I ever began solving this problem. I should have noted what x cannot be. X cannot be equal to -3, and x cannot be equal to +2. Why? Because if x is equal to -3, -3 plus 3 is 0, 3 divided by 0 is undefined. Cannot have an undefined term. X cannot be equal to 2 because 2 minus 2 would be 0, 1 over 0, undefined. Alright, so I have x is equal to -8. I don't have an answer key for you, so let's check. We're going to plug this back into the original problem. So I have 3 over a -8 plus 3 is equal to 5 over 2 times a -8 plus 6 plus 1 over a -8 minus 2. Alright, so we get 3 over a -5 is equal to 5 over, alright, 2 times -8 is a -16, plus 6 is going to be a -10, plus 1 over a -10. Oh, I love this. This works out so nicely. Alright, so we can combine these two terms. Why can we combine those two terms? Because they have the same denominator. In fact, I'm just going to leave that negative down below. 5 plus 1 becomes a 6 over a -10. And then what does 6 over -10 simplify to? How can you simplify 6 over -10? Divide by 2, divide by 2, and what do you get? They're equal to each other. So, backing up, there they get the -8. Makes sense? Does the check process make sense? Yes? How about from the ladies in the back? Alright. So, you can check your problems as you're going through it. This is something I encourage you to do. Go through that check process. You could have plugged this into a calculator, but I don't know. For me, it's just quicker just to do the math. And you can see it's not that difficult. This worked out beautifully. Yeah, I had fractions, but look, these two were the same term, same denominator. Just combine them together. We end up with this, simplify it, and it makes the other side. Beautiful. All right, what else can we look at?
Can you go over 12?
Yes, ma'am. All right, this is another type of problem. You kind of see these problems repeated. You could classify this as problem number 11. You could call this a mixture problem. It works the same way. Wait, problem number 12, sorry. Did you say 12 or 11?
12.
12. Alright, what you have is you have $11,000. And this is being split into two accounts. You're splitting this investment. So part of it is going into an account that paid 5% annual interest, and the other part is paying 8% annual interest. And when we go back and look at the combination of these two accounts, we get the $730. So an account is being split up into, or an amount is being split up into two accounts, and then a percentage of each of those amounts is going to give us the $730. So let's call this account 1 and account ACCT 2. So here's just a little thought. If X amount goes into account 1, then blank amount goes into account 2. Let's fill in the blank. So here's a question, and you're going to answer this for me. If I put $9,000 into account 1, how much goes into account 2? You tell me.
$2,000?
How'd you come up with 2,000?
I subtracted the 9,000 from the 11,000 total.
Bingo. So if I said 3,000 went into account 1, how much goes into account 2? You tell me.
8,000.
How'd you get that?
You just subtract the total from account 1 out of 11,000.
Bingo. So guess what? Then 11,000 minus X amount goes into account 2. If X amount goes in account 1, then take the difference, 11,000 minus X, and that goes in account 2. So here's your equation. So we're going to convert these percentages to decimal numbers. 5% is equivalent to 0.05. So 0.05 times X plus 0.08 times 11,000 minus X. So 5% of the amount that went in account 1 plus 8% of the amount that went into account 2 has to equal the 7,300. Before we move on, this equation has to make sense. So look at our illustration. Back up here, we split $11,000 into two accounts. One account paying $5,000, the other account paying one account paying 5%, the other account paying 8%. Once we take these percentages and put them back together, the total is 730. So X is the amount from account 1. 11,000 minus X is the amount from account 2. So 5% of account 1 plus 8% of account 2 equals 730. Does this equation make sense? Yes or no? Yes. I see two, yes. I see a third one. So go through and solve. Um, 8% of 11,000. You know, this is where I'm going to use my calculator. 880 minus 0.08x is equal to 730. Alright, so 0.5x minus 0.8x is going to be a negative 0.03x. I'm going to subtract 80 on both sides, so that's going to give me 150, but that's going to be negative. 730 minus 880, it's going to be negative 150. We'll divide both sides by a negative 0.3 on both sides. And what do we get? We get that x is equal to...
Sir,
Yes, ma'am?
you forgot it. You forgot a 3 in 0.03.
Yeah, I
Forgot a
forgot
0.
I forgot a 0. $5,000. X is equal to 5,000. So, the question is how much was invested at each rate. Now, X is the amount that goes into account 1. What did the account 1 represent? The 5%. So we can say the following. 5,000 at 5%. And what goes right here? What amount? You tell me.
6,000.
6,000 at 8%. So, you know, this is probably I like these word problems. I don't know how often I test you over these, but this is a great word problem. And they're all built the exact same way. You begin with an initial amount. You declare that it's being split into two accounts, where each account is at some rate, and you're given the total amount of interest earned. And they're all built the exact same way. And then you just have to go through and develop your equation that's going to be used to solve. Okay. Any questions on that problem or another problem that you want to look at?
Uh, 26.
26. I'm glad you asked that. This is my 9th year here at SVC. So in the 8 years of teaching and probably having a college algebra class just about every semester, I'm pretty sure that every exam one, every college algebra class has had a question that said, solve by completing the square. To receive full credit, you show me the process of completing the square. I would give you credit if you solve the problem by quadratic formula, but you're not going to get full credit. I get full credit for a problem, you got to solve by completing the square. So we're going to go through that process. Step 1. To solve by completing the square, you got to get the constant to the other side. That's always step 1. Not 10, but 11. Step 2. We're going to add b over 2 quantity squared to both sides. So the b is the -6. Remember, the format for a quadratic equation is ax squared plus bx plus c is equal to 0. B is the coefficient of the x. So we're going to add b over 2 quantity squared to both sides. So we're going to take x squared minus 6x plus a -6 over 2 quantity squared equals 11 plus a -6 over 2 quantity squared. Alright, so what do we get? -6 divided by 2 is 3. Excuse me, -3. But -3 squared is a positive 9. Now, the next thing that we're going to do is we're going to factor. Now, the point of completing the square is that what you do is you create a perfect square trinomial. And this trinomial is factored form. It's going to be x minus 3 quantity squared. So there's something to be thinking about here. X squared plus bx plus b over 2 quantity squared is always equal to x plus b over 2 squared. Every single time. Every single time that you complete the square, the factored form is going to be x combined with whatever b over 2 was. What was b over 2? The -6 over 2. -6 over 2 is the -3, so you're going to have x minus 3, and you're going to do quantity squared. And then 11 plus 9 is going to be 18. And now we're going to solve with the square root property.
Shouldn't it be 20 instead of 18?
20, sure, why not? 20. I do have my moments. 20. So we're going to square root both sides. What do we always include when we square root both sides? The plus or minus notation. So we have x minus 3 is equal to plus or minus. Alright, square root of 20. A little bit of side work real quickly. Square root of 20, that's equal to the square root of 4 times 5, which is equal to the square root of 4 times the square root of 5, which is equal to 2 times the square root of 5. So x is equal to 3 plus or minus 2 square roots of 5. There's our answer. Now, let's talk about the check process here. two ways that you could check. You could check with a calculator. So you could type in 3 plus 2 times the square root of 5. In fact, I'm going to show you how to do this with a calculator. So I'm going to let x be equal to 3 plus 2 square root of 5. So in my calculator, if I can see this, there we go. I'm going to clear that out. I'm going to do 3 plus 2 square root, where's my square root? Second square root of 5. Hit enter. Now, we get a 7.47 blah, 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 blah. I'm going to keep this number in my calculator. So I'm going to go back to the original problem where you had x squared minus 6x minus 11 set equal to 0. The nice thing about this calculator and a lot of calculators is they will store your answer. So this answer is already stored in my calculator as what's called ANS, answer. I'm not going to teach you how to use your calculator. You learn your calculator, learn how to store numbers. But here's what I'm going to do. I'm going to do ANS squared minus 6 times the ANS minus 11, where ANS stands for answer. So here we go. I'm going to do second answer squared minus 6 times the second answer minus 11. Hit enter. 0. 0, that's what it equals, 0. So 3 plus 2 square root of 5 equals 0. What about 3 minus 2 square root of 5? The nice thing I like about this calculator is I don't have to type in things twice. So I'm going to use my up arrow. I'm going to go up, up. So this takes me back to the 3 plus 2 square root of 5. I'm going to change that plus to a subtraction sign. Hit enter. Now this is my answer. Negative 1.47 blah, blah, blah. So I'm going to hit up again to where I typed in this. So the answer now is using the negative 1.47. This answer is recalling the previous computation. Hit enter. 0 again. That's how I can use my calculator to check. Or you could use the quadratic formula. Quadratic formula, if you go through the quadratic formula using our A, B, and C here, you're going to get the exact same thing over here. I'll let you do the quadratic formula unless you want me to see. Do you want to see the quadratic formula worked out here? No? Yes? No? Okay. What else can we look at?
Mr. Clopton,
Yes, ma'am.
is it okay if I go to the restroom real quick and I'll just copy the notes from my classmate?
Yeah, so remember, I think I've already mentioned this, I can't remember, but you don't have to ask me permission to go use the restroom. You don't have to ask me permission. Welcome to college. College is is freedom. You get to do what you want. All right, so y'all are still in a high school setting, so maybe you have to ask your teacher for a hall pass. I don't know, but in college you get to do what you want. It's freedom. Now there's consequences to your choices. Consequences is not a negative word. You can have positive consequences or negative consequences. So there are consequences to your decision. If you choose not to show up to class, well, the consequence is you don't learn the material. If you choose to show up to class and you study the material, the consequence is you understand the material. So, anyways, choices. No one's keeping tabs on you in college. You're like, man, I can't wait to go to college. Get out of my house. No more parents. Nobody telling me what to do. Yeah, enjoy it. Enjoy it. Consequences. 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 All right, what else can we look at?
31.
31. Ooh, solve by any method. Fun. All right, I need to clear out my. Here we go. $31. 9y to the third plus 8 is equal to 4y plus an 18y squared. Alright, so when I look at this problem, the first thing I notice is this 9y to the third. So, since I have an exponent of 3, the only time that we've come across exponents of 3 are with solving polynomial equations. So, this is telling me that I have a polynomial equation which means that I'm going to solve by factoring. Now, if you're going to solve by factoring, one of the first things that you got to do is you got to set your equation equal to 0. So what are we going to do to set this equation equal to 0? I'm going to subtract the 4y, subtract the 18y squared on both sides. Now, there's something I just don't like about the way that this is set up. I don't like the fact that my terms are not in descending order. Typically, we like to have our terms such that your highest degree term is first, then the next highest, the next highest. So we want to spend some time to reorder this equation. So perhaps we would have 9y to the third minus 18y squared minus 4y plus 8. Alright, so how do we factor a 4-termed polynomial? To factor 4 terms, we're going to factor by grouping. We're going to factor by grouping. So I'm going to group the first 2 terms together and the last 2 terms together. So when I look at these groups, now a couple of things. This is not, I'm not indicating that we're multiplying. In fact, Really, if I'm being really technical, there should be a plus sign between these two sets of parentheses. But you put the first two terms in a group, you put the last two terms in a group, and then we ask ourselves, well, what is the GCF of each group? Well, the GCF of the first group is going to be a 9y squared. 9 is the GCF of 9 and 18, and both terms have have at least a y squared. The GCF of the second group, now pay attention, you can't really see it, so I'm going to reiterate it. There is a negative sign with that 4. So anytime your first term is negative, your GCF is going to be negative. And what can we factor out of a 4y and an 8? You can factor out a 4. In this case, a negative 4. So what does this give us? This gives us now 9y squared times y minus 2. Then we factor out the negative 4, and that's going to give us a y minus 2. Now, if you factor by grouping, and you do it correctly, you should have a common factor here and here. These two terms, these two sets of parentheses should be the exact same. If they're not, then you didn't factor by grouping correctly. And chances are it means that you didn't factor out the correct GCF here. If you factor out the negative 4, then you see that you get y minus 2 here, y minus 2 over here. So the way I write it is, what do they have in common? They have the y minus 2 in common. What are my leftovers? What's left? The 9y squared minus 4 equals 0. Now, always think about factoring completely. Factor completely. So this binomial can't be factored, but this guy can. It's the difference of two squares. 9 and 4, both perfect squares. So I can factor this. Think about two binomials. The square root of the first term is a 3y. We're going to have plus minus square root of 4 is 2. This is all set equal to 0. Now, we're going to set each factor equal to 0. This is called the zero product principle. Something times something times something equals 0. Something has to equal 0. So we can say that y minus 2 is equal to 0, or 3y plus 2 is equal to 0, or 3y minus 2 is equal to 0. So what do we get? We get y is equal to 2. We get y is equal to subtract 2 divided by 3, so that's going to be negative 2/3. Add 2 divided by 3, that's going to be a positive 2/3. And there's our three solutions. Alright, probably got time for one more question if there is one. You could use your calculator to check any of these answers. I would, again, do something like this. Let your answer, I would do, well, we don't have time. And why is my pen not working? I don't know. I love my iPad, but sometimes it just does not want to behave. Alright.